Hello and welcome back to the course on artificial intelligence. In today's tutorial, we're starting off this section on deep convolutional Q-learning. So let's have a look at what it's all about. Previously, we talked about deep Q-learning. So we had an environment with an agent, and we had a vector describing that environment, which was fed into a neural network, and at the end, we got the Q values as our outputs. And then, of course, we found out how the network is trained, the learning part. We found out how actions are decided based on those Q values. That's an action part. And we talked about the action selection policies and different things about how deep Q learning works. But here, the key concept for all of this is how do we get from the actual environment and the states, to the neural network? Well, the transition is over here, the input vector. So the input layer of our neural network, and it is a vector. So what we're looking at is, okay, so we're actually not the correct, it's not the correct term. We're not looking at anything. The agent basically has this information. So the environment is passing it this information saying, okay, you, the agent, you're currently in your state is described by this vector. In this simplified example, it's described by this vector x1 of 1, x2 of 2. So your coordinates are 1, 2, and that is your whole state. In a more complex environment, the state might involve other things that the agent can be observing. But the point here is that it is passed as a vector. And the thing is that doesn't happen in real life. In real life, except for GPS systems and other things like that, but in real life, what do we use most of the time? We use our senses. We use our eyes. Even in GPS, it's not built into our brain. It's not telling us the coordinates through our brain. And so we're still using our eyes to look at the GPS and understand what's going on there. And so this is kind of cheating for AI to be able to get information about the environment as a vector. It's too simple. It's not how it works in real life. That's not how we as humans operate. And ultimately, we want to create artificial intelligence which can operate in a similar fashion to humans, which is as can take on the same challenges as humans. And so in the human world, we don't have that. We don't have these coordinates or other types of vectors that are passed to us that explain the state we're in that environment. So we're going to have to remove that to make it more realistic. And then what can we replace it with? What do we see, or what do we do as a human to get information? Well, most of the time we see. Of course, we use all of our senses, but most of the information that we're getting about the world around us comes through our sight. And that is why we're going to change that little arrow which we had into a whole convolutional neural network. So this is from our annex number 2. We've got the convolution layer, and that's why it's important to be quite comfortable with convolutional neural networks and how they work. So if you've done our deep learning course, then you should be comfortable with that, or you can just have a look at the annex number 2. We've got some very good intuition tutorials there. So here we've got the convolution operation which happens. So we're actually going to be looking at this as an image. So this is an image of net environment, and so the agent is actually looking at the environment. So in this case, not that he's looking from within there, he's looking, let's say he's playing this on a computer and he can see this environment, and therefore he can see where this figure representing the agent is actually is. So you can see this whole environment, or whatever a human would see. If it's actual maze, then the human would see the maze from inside, and so the agent should be able to see exactly the same thing. So whatever he sees is goes through a convolutional layer, then goes through a pooling layer, goes through flattening. Again, you can find out more about these different parts of the convolutional neural network in the annex. And then after it's flattened, then we have inputs which go into the neural network. And this is way more realistic because the agent has to use their sight, or has to process images which the environment is supplying to the agent, just as a human would be processing images. And the beauty of this is not just that it's more realistic and it's kind of more as the agent's actually more as a human would be, but it allows us to process much more complex environments. For instance, this is how we can play Doom or other games like that, because instead of just getting a vector of information, which somebody would have created for us in this environment. We can just hook up our artificial intelligence to any environment, which as humans, we would have a vision of this environment. So we, as a human, when you're playing this game, you can see exactly this picture. And that's exactly what the artificial neural network or the agent would see now. So in this part of the course, when you're going to be programming the practical tutorials, the agent will actually see this exact picture. It will see the pixels. It will get this exact picture of all of the pixels with this person, with this gun, with this face, with this percentage, with everything. Exactly what we see here. That's exactly what the agent will see. Then it will have to dissect that through convolutional layer, pooling layer, flattening, and then it will go into a neural network. And needless to say that the neural network will actually be much more complex than that. So let's replace it with something like this. This is not much more complex. This is looks a little bit more complex, but in reality, the neural networks you're going to be working with and creating with Adlan are going to be quite interesting. They're going to be much more complex than this. But as you can see already here, even if we just have 5 inputs instead of 2, things become much more complex. And here you can see we have many more actions that the agent can take. So in the game of Doom, turn left, turn right, look down, look up, run, shoot, reload, or all those different actions that are possible in first-person shooter like Doom. And moreover, it doesn't have to be that. You can attach this agent to another type of game. That's the beauty of it, that it then realizes that it can now operate any kind of environment that you attach it to, because as long as there's like a visual representation of that environment, it's already got the whole infrastructure, the whole structure is ready to process that. So that's what deep convolutional Q-learning is all about. So we're taking it even to the next step. We're adding convolutions into, or the convolutional layers into our agent's brain now. And we're making it even more complex, and therefore we're rewarded with being able to solve even more complex challenges. So I hope you're very excited about this. This is going to be an epic section, and we're going to create some amazing things. And I can't wait to see you on the next tutorial. And until then, enjoy AI.